Hello everyone, I am Tang Xuanzhang from China's Sun Yat-sen University. My tutor is Professor Yu Yang and comes from School of Data and Computer Science. I'm sorry that I am unable to attend these conferences for some reason, so I prepared this video to share my research with you. The paper I report today is a workflow interoperability approach based on the blockchain. Workflow interoperability is the ability to communicate and interact between two or more workflow engines to enable collaboration and execution of process instances across engines. There are two problems with early interoperability research. One involves the credibility of interoperability, especially the lack of credibility when workflow execution services interoperate across organizational boundaries. Another problem is that early researchers lacked a modern approach to interoperate message sequences and could not logically express a complete multi-party cross-organizational cooperation process. To make my description easier to understand, I used an example from Interoperability. You can see the picture. In the picture, middleman handed the goods to special carrier. When the manufacturer received the goods, the quantity found was inconsistent with the quantity when he placed the order. At this time, due to the lack of reliable verification method, it was impossible to confirm that the goods lots was in transit or in the process deducted by the middleman. At the same time, because the interaction methods are not clear, they do not even have a unified interaction with each other. In many cases, traditional methods such as mail, invoices, or third-party platforms are used. This method lacks efficiency and is not convenient for subsequent accountability and so on. From the above examples, the practical problems are questioned when these two problems lead to interoperability from the technical research level to the technical implementation level. Therefore, we propose a blockchain-based workflow interoperability status as the core, mainly through improved workflow execution service interoperability interface and workflow execution service calling collaboration service to support. In this approach, the workflow execution service invokes the interoperability service through an interoperable interface that utilizes smart contracts to manipulate data from the blockchain. Below, I will describe the method I provide. So, what are the problems with cross-process interoperability? The first problem I want to say is why we use blockchain. A blockchain is not a specific technology, but a solution consisting of multiple technologies. The essence of the blockchain is a continuously growing distributed database that is jointly maintained by multiple parties, also known as distributed shared ledgers. At its core is a distributed network, time-insensitive cryptographic books and distributed consensus mechanism to establish trust relationships with each other. Using smart contracts composed of automated scripts to program and manipulate data, and its distributed network, timing cannot be tampering, and trust mechanisms can just solve the problem we raised before. And how did we use it to solve the problem? So first, let's have a look of the overview of our method. Because workflow performs service interoperability, the data passed by the interoperability interface is closely related to the execution of the internal process instance of the collaborator. So, it is necessary to record the data. The record of the data must be non-temporable, which can help to track the process when the process collaboration is run. We use the blockchain technology that has received much attention in recent years to store data transmitted by interoperable interfaces. Nodes participating in the blockchain system may not belong to the same organization and do not need to trust each other. All nodes jointly maintain data on the blockchain, and each participating node maintains a complete record copy. The workflow execution service sends messages over a blockchain on a particular process node, view and update the process instance interoperability status on the blockchain when the workflow execution service interoperates. Changes in the interoperability status of process instances on the blockchain can notify the collaborators in a timely manner. At the same time, when the workflow execution service is interoperable, the participants include the witnesses, and the data transmitted by the interoperation interface will be distributed and stored through the consensus algorithm of the blockchain technology, which ensures the integrity and consistency of the data. The blockchain timing cannot be tempered to ensure data traceability and security. And after the overview, let's look some definitions within the method. Interoperability messenger is information exchanged when two workflows perform service interoperation. The IM should include data that is needed for a workflow execution service to interoperate with another workflow execution service, such as process-related data, application data, and process control data. The IM can be used to request another workflow to execute a service creation process instance, or to request a process instance to perform a specific task, and the like. Interoperability event is a pre-public event on the process. The internal processes in the workflow execution service interoperate with external processes through such process nodes. There may be several IEs in a process. IE can influence the execution of the process. The interoperability event to send messenger is the IE that sends the IM. If the workflow execution service sends IAM at the IESM, it affects the execution of process instances of other workflow execution services. The interoperability event to receive messenger is the IE that receives the IM. If the workflow execution service receives an IM at the IERM, it affects the execution of the process instance of its own workflow execution service. The rule of interoperability messenger path. The rule of the interoperability messenger path is a rule that the workflow execution service needs to satisfy when delivering IM through IE. In our approach, workflow execution service interoperates, and workflow execution services needs to pass IM through a pair of IEs. The rule requires that the sender is IESM and can be of message start event or message intermediate event type. The receiver is IERM, which can be of message intermediate event or message end event type. Process instance interoperability status is an important concept, a process for expressing a state after the completion of one example of interoperability. PIRS can be represented by a set of two elements, R and IM. where element R is a binary relationship, which is a set of two ordered pairs, which is used to describe the current process instance interoperate once with which process instance, and interoperation is performed by which IE. Another element IM indicating the times for transmission of interoperability, and F represents the correspondence between any two different PIIs. The process instance interoperability state sequence can express the transition of the interoperability state of a process instance in the workflow execution service in the life cycle. And after the definition, let's look at the process. The workflow execution service can publish IM or PIIs into the blockchain and add access rights for other workflow execution services to listen. All workflow execution services do not need to be directly linked to each other, but in the blockchain, pluggable dynamic links driven by changes in IM or PIIs on the blockchain. In our approach, the blockchain plays such a shared database role, and the workflow execution service can communicate and interoperate directly through the blockchain. Our interoperability interface provides 6 functions for workflow execution services, namely sending IM, sending PIIs, receiving IM, receiving PIIs, querying IM, and querying PIIs. First is sending IM. The workflow execution service through an IM as the process IESM and stores it in the blockchain through the interoperability service. The IM is set to read permissions, can be read by the specified recipient and used to create process instance or perform specific activities in the process instance. Receive IM. The workflow execution service uses the interoperability service to monitor whether there is a change in the blockchain at the process IEIM, and receives the specific IM on the blockchain through the permission interoperability service. The IM can be used by the recipient to create a process instance or perform a specific activity in the process instance. Sending PIIs and store your PIIs on the blockchain through interoperability services. The PIIs is set to read permissions and can be read by the specific workflow execution service. In fact, the workflow execution service is different at the IESM and IERM of the process, and the send PIIs function of the interoperability interface is called. As the IM receiver, you only need to send the IM at the IERM and execute the internal logic. Then you can send PIIs on the IERM. As the IM sender, you need to send the IM at the IESM and wait until the IM receiver completes its own internal logic. After that, you can send PIIs on the IESM. Receiving PIIs. The workflow execution service uses the interoperability service to monitor whether the blockchain changes, and use the interoperability service to capture PIIs on the blockchain. The receiver can use these PIIs to understand the completion of the other parties in an interoperation. Query IM and query the IM history records generated by interoperability will let the workflow execution service through to read the interoperability history through interoperability service. It can be used for tracing and verification. query PIS and query the PIS history records generated by interoperability with other workflow execution services through the interoperability service. It can be used for tracing and verification. And I will prepare an example for this. We use the example to introduce how the workflow execution service communicates between the IESM of the process and the IERM of the process through the interoperability interface. The middleman workflow execution service. Let's look at the picture. The middleman workflow execution service at a process forward order event sends an IM, and the supplier workflow execution service captures the IM and executes the internal logic at the receive order event of the process. Here, middleman's forward order event is IESM, and the supplier's receive order event in IERM. In fact, in the interoperability process, the two workflow execution services need to call 5 interoperability interfaces in total. First, middleman sends the IM as a forward order event, where the IM includes the data that is required to request the supplier to create a process instance. After that, the supplier receives the IM at the receive order event. After the supplier completes its internal logic, it sends PIS at the receive order event, and middleman receives PIS at the forward order event. Finally, middleman sends PIS at the forward order event. In fact, these 5 steps are equivalent to using request and response messages to communicate. Supplier requests middleman to create process instance and start process instance. This communication process is distributed in the blockchain known and let's have a conclusion. In this paper, we present a flexible and reliable interoperability method based on blockchain technology. The method is based on the management of IM and PIS on the blockchain, and is mainly supported by the expansion of interoperable interfaces and interoperability services. The workflow execution service and the blockchains are connected through an interoperable interface, which acts as a connector between the workflow execution service and the blockchain, and is capable of operating IM and PIS on the blockchain. This method uses the blockchain as a shared database. When the workflow execution service interoperates through this method, IM and PIS will perform chain storage on the blockchain. We care about IM and PIS management, using smart contracts to set up IM and PIS transaction functions so that workflow execution service can operate on IM and PIS through interoperable interfaces and interoperable services. All workflow execution services do not need to be directly linked to each other, but are pluggable dynamic links on the blockchain, and interoperability between them is driven by changes in IM and PIS on the blockchain. This model ensures that interoperable message sequences are trusted and time series, and the interoperability of multiple workflow execution services can flexibly express a complete cross-organizational cooperation. In this environment, we implemented the prototype of the interoperability model and experiment with 2 collaborative sensories, using multiple workflow engines to manage an internal process. And different workflow execution services interoperate through the prototype. In addition, our model supports 4 interoperability models in the workflow reference model, supporting 5 interoperable keys, use cases and 5 high-level interoperability features with privacy, credibility, and flexibility. And for the future work, the improvement of the interoperability interface in our method may not be complete. At present, only 3 event types in the BPM 2.0 standard are supported, namely message start event, message intermediate event, message end event. Further research on the improvement of the interoperability interface is needed to support more elements in the BPM 2.0 standard, including activity. Although workflow interoperability generates are most low-frequency transactions, we still need to study the situation that workflow interoperability may have low latency requirements and improve the practicability of interoperability methods. At the same time, the trust mechanism of the thesis is mainly due to the characteristics of the blockchain. We need to have a deeper understanding of the blockchain mechanism and improve the reliability of the blockchain-based interoperability method. We will also consider more of the interoperability standards of the workflow management alliance specification, including obtaining process instance properties, listing process instances, changing process instance probability, setting process instance probability, and terminating process instances. And that's all for my presentation. Thank you for listening.